Hello everyone, my name is Faisal Khalil and welcome to another tutorial for Practitioner Essential, AWS Cloud Practitioner Essential, and this is module number 5. So today we are going to discuss first that what is the storage and database in the AWS, what's the purpose, what are the use cases, and in which use case what to use. We'll discuss some practical question in the exam. We'll practice them, and later on we'll test some stuff in the AWS console in the real time as a hand-on lab to check that how stuff works. So yeah, let's get started. So basically, for the storage of any object or any file or any any kind of data, you always need some storage. So in this connection, Amazon provided different intensive options plus some services to manage those options. The important thing is that these options were already around in the market, but the good thing for the cloud providers and in general AWS that they provide a managed service which you have to focus on the quality and concept itself, but a lot of administrative and other patching and backing up and administrative tasks of the databases or migration of databases. In the past, these tasks would cost a lot of money to hire the experts to do stuff, but nowadays it's just a matter of a person who knows AWS in deep could easily do that tasks. Plus, there are a lot of automatic services already available on the front end level of the AWS console. So this is a great thing for the cloud. So in general, for the storage, not for the AWS, there is a different concept of storage. So one of the storages we have seen in the 90s or late 80s, actually, the hard disk. And hard disk would always steel revolving plate, and there was some block or this sector on it, and data would be written on those block, and it is then erasable and rewrite and readable. So this is the similar concept AWS use along with some other resources, and S3 is a well-renowned option and some other services alongside. So other type of hard policies, you can say in the other word, which we could in general attach to the AWS storage based on our needs. So there are a lot of stuff actually which you're gonna cover. So let's see that what are the storage options. Block storage, as I said, is similar to what storage works in the traditional hard disk where you can read and write on the block. Object storage is sometimes like image and videos and some dump file which you don't need to rewrite again and again, and you don't need to modify and manipulate. Is kind of that structure. In file storage type is the general file. For example, if you're writing some program and you have some shared library, and this shared library is in the end used by different entities like application, user, other computer, blah blah blah. So yeah. Now there's a different styles, and file storage is a simple files shared by different resources. Block storage, as I said, this is you can just take it a simple block data where you can write, read, access, rewrite. So normally there are two type of storage which could be attached to any EC2 instance. For example, you have seen that when you go to the EC2 instance and you create a EC2 instance, it asks you that which kind of volume or which kind of data storage you want to attach to it. Because without data storage, it is just simple, a simple EC2. Because, for example, I go to the EC2 here, I launch instance, and here I test EC2 test storage. So for example, I choose this one here and I come here, and this is the instance type. There are different type of instance always which you could choose, right? Small, medium, whatever. And then there is always volume configuration, which is here. And as you can see that there is a different type of volume right here. Like it is standard magnetic, this is SSD or GP2 based and IO1 based. So these volume are very important here. For example, this is always EBS volume, right? Elastic, I don't know, Elastic, Amazon Elastic file system or whatever volume it is. So sure you did. You can also go to the EFS, Elastic File System, or FX. So there are kind of different Elastic File System. It's a file system which is scalable, shrink or expand automatically based on your use cases and stuff like that. And this is more use case optimally where you need to run your application and the resources are shared by across the different services. For example, user, different services or server or different applications share some resources and you need to read, write and dynamically change a lot. Then you need this thing. This is for some special use case. This is not that one. And here you can see that this is EBS volume here, but so this is the difference here. Actually, you can also just create without attaching this volume. You can just create an instance type. Type is just whatever kind of type you're using, big, small, that one. And this is the storage volume detail, right? So this volume saves your data always, regardless if you terminate your instance or not, right? And you can also launch without this storage system as well, right? Here are some advanced details you want to select. So for example, you can create a directory or whatever profiles and IP names and what happened when for example, what happens actually when you shut down and GPU and credit and a lot of other actually stuff. Best reservation, metadata accessible. So these are the advanced options. So yeah, so that's that, for example. And here we can really attach the instant store of the data. And this when you really terminate or cancel or kill your EC2 instance, and everything, all the instance resources that has been attached to any service will be deleted or gone. So this is number one. What is the alternate? The alternate is EBS volume, right? Yes, that was the abbreviation of Amazon Elastic Block. So why they call it block? Block, the similar block. In the Linux, you use ls blk list block for the disk management operation, or in the past we have seen big disk. This is the similar concept, which is really great. And you can also attach to the other resources, not only to this EC2, or EC2 is the most usable and viable way to use it, but you can use it other way around as well. So for example, you can create it as a storage, but yeah, for example, then EBS has block system has a very beautiful service which backed up your data every day, for example, or you can periodically back up your data. But backing up is sometimes costly because you're storing or copying your data again and again. But EBS is doing this in a smarter way, which smarter way that it only backup the second day the file that has been changed, not the whole database the second day as well. For example, in your organization you have policy that you back up whatever your database every day, or whatever your storage volume is every day. And if you're storing every day, then definitely you're just creating a copy of the same data, but in an incremental way. For example, this is creating the path to this data. So this data is already backup at the day one, and this create a log or a 1 KB address that where this data resides, and on top this is backup. And then third day and fourth day, and building a snapshot. This is called actually snapshot, right? This is a snapshot concept of the block, and instance and EBS. The big difference between these two, that instances are temporary and they delete on the termination of the instances, EC2 instances. However, EBS is volume, and your data is always kept, and you can use them. You can reattach to any other instance, or blah blah blah. Well, then when it comes to data storage in volume, when we always talk about the volume, it is sound like a hard drive in the past, and it's very similar concept with block on the hard drives. Okay, it's true that nowadays these computers come with SSD, like solid state drives that are on motherboard, not a big disk, but still they are same. They are not same, but they are kindly functioning in the same mechanism, right? Then the another storage type comes up into the picture is the object storage. For example, you have bulk of images, you have videos, and you have some other documents which you want to store. There could be different need for the different organization. For example, some data you need daily to retrieve, some data you don't need, you need very less frequently, you need that data some days, and some data you don't need instantly, but you want to not lose it, because might be there is chances that you could need or you might have need that data someday, and that is kind of archiving where you store your data. So these are kind of how these kind of topics are come under the object, and AWS a very beautiful service and very famous as well, S3 bucket. AWS S3 bucket. So this bucket has how it works is it store the data inside it. It set the permission and control access policies. For example, you can say that you can allow all the txt file in your access control object list, or you can say that if the request come from that specific place, please. So there's some security mechanism which is very similar to the access control list ACLs, right? It is kind of similar to the ACLs, but yeah. So fine. So yeah, that's that. That's that. And then actually kind of well, so there could be different needs for that, right? And we'll explore that how AWS different policies catering this. So these are three different storage class or policies which is attached, or which are normally could be attachable to any S3 bucket, which is S3 standard as a standard, so kind of default option, which available on 3 availability zones, and 1 availability zone crashes. Second is available, it's highly available, designed for frequently accessible data which you need it. IEA means infrequent access, and this S3 infrequent access data is always needed actually when you need data sometime, but to reduce the cost actually you could attach this standard, right? This is lower cost. And sometimes there is S3 one zone IEA, because there sometimes your data is not that important that you want to create a 3 zone, the topmost highly availability standard practice for that data, but you could afford actually only 1 zone. And second feature is that your data is not you don't access it very frequently. You could attach on more lower prices this IEA zone, right? These are the 3 prices, for example. And then comes this AWS S3 storage classes. Well, These three storage classes or four storage classes are come after the standard storage classes. These are serving the archiving purpose, and by archiving purpose I mean that there are some kind of data which you want to dump somewhere, and you think might be I need that data in future sometime someday. And the Glacier service, the is S3 Glacier means that cold data which you don't use it. This is the relevancy, or this is the metaphorical name of that cold data. And then flexible in retrieval means that this data is sometimes you need that data when you need it urgently. For example, you come to know that today I need some data, but you want to have that data immediately. Then based on that time, you can configure this retrieval process. Instant retrieval, instantly available millisecond. Flexible retrieval means that a minute to hours. You are flexible with respect to times. If you come to know today that I need data from 2012 archive, and it's okay if data is delivered in 2 hours, it's good for you. And sometimes you need to have a deep archive. And the deep archive is that you need to know that when you need data at least 12 hours before. So these are the some okay. And what is that that intelligent stuff is that for example, you don't know which kind of data you have and where from it's coming. Sometimes it does happen because your data is uploaded by your users, and you don't know what kind of data they upload, right? And you don't know any patterns, how and when and how frequently they upload this, and how frequently they need the data. For example, you are giving them some image or file or document. Sometimes they use some images more frequently, some images they don't use for the years, for example their photo or something like that. And the intelligent tiering system, what it does, it records that how frequently any user use that data, and the data which user mostly use with respect to usability and pattern of the use, it's automatically keep here in the upper level of availability, and all those data which user don't use frequently is automatically shifted to the Glacier based on their retrieval time and stuff, which means that this automatically management reduce your cost significantly, because it's automatically dumping the data which is less frequently called by the user, which means that all on those data you pay less price because it's shifted to the highly available or instant retrieval Glaciers. And however, you pay price only for the data which is frequently used. And this is a great feature, I would say, to reduce the cost. Here you want to access the data infrequently accessed but must immediately available when needed. Yeah, definitely. With flexible retrieval that doesn't work, deep archive doesn't work, S3 in standard, that could be the option, right? Because you need it instantly, right? And file storage system. Next comes file storage system. As I have discussed in that file storage system, that sometimes your storage works like application server way, where many parties want to use those files on a shared basis. In such a way, you need that elastic file system, and Amazon stores your data in the scalable file, and it's made them available whatever party need them in the end, which is which. And yeah, then this is the end of the topic file storage, and then come databases and databases type, and we'll quickly discuss what are the type of databases and why we use them. So for example, that there are two type of databases. One is relational database and non-relational database, and there is another type called graph-based DBs. right? This is the graph-based DBs as well, right? So this is the another database service, but we'll might discuss in the future. It most important that highly connected relation-based stuff. For example, Facebook ID, number of followers and like, and some recommendation based on it. So in that kind of database, you always put up the relation of the data. For example, you say that the Facebook ID and follow has direct relation, and you write this arrow. And some other feature which is less important, it doesn't give them arrow, and in the end it map those graph of relationship, which relationship is more important or not. That is emerging, and there's another database which is vector-based data, vector-based data database, which is for machine learning, very important, where you not store anything, but you store like matrices. You store like matrices 0, 1, 1, 2, 3, whatever data in multi-dimensional space. Actually, you create them and you store the matrices column for the training purpose, or tensor maybe, and something like that. So these are, for example, Cosmo is the one approach. But here, what is the back to the topic? What is the difference between the relational and non-relational database? A relational database is everything has a mapped relationship. For example, first column we have ID, the second column is product name, and for that product name we have size, and for that size we have so we are talking about always this ID when we are talking about these columns, and all the column are correspond to this identity, this entity here. Entity number 2 is 2, and whenever we talk about anything, we are talking about all this stuff which is here, right? And this means that this is a relational database, and with the query setup we can always select, we can say that select all the rows from T1 where price is equal to $5 or greater than 5, and it's gonna parse through and give us subtable which will give us all the column and rows where the price is more than 5, something like that. These are the normal SQL use cases where we can join the table, merge the table, join into, join onto, join outer, inner joins, and those kind of relationship. That is classical way of doing stuff from the application and other server. But sometimes, or the best of time, the data digitalization require the modernization of data set, which means that sometimes people don't care about anything relationship map between the entities, but they only cares about that there is some key, and against that key there is some value. And what is the benefit? That we can dump a lot of data. Even this could be a whole document, this could be a whole picture pixels, or pixel of something else, or matrices of something else, and that makes the life more easier if you have key value pair style. And AWS has Dynamo DB for that. So we'll discuss everything in detail. So, well, AWS is enriched with a lot of options, actually, very gladly and thankfully. And one of that service which automate a lot of stuff is AWS relational database services. This database management services is fully managed services designed by AWS and specifically designed for the relational databases, because AWS has a clear segregation between relational and non-relational databases, where actually what you do is that because there are a lot of administrative tasks, you need to create a user, you need to create different permissions, you need to backup, patching, mapping, and a lot of stuff. These all stuffs are made sure by this DBS service. For example, sometimes you need a migration of database from one place to the other place, and in those cases no worries, database could easily, this AWS services RDS could come into the picture. So this is the beauty of cloud, that cloud server provider, because of the competition, provide you a lot of IT stuff which in past needed a full-fledged expert with high salaries to do. And other than maintaining the cost of the cold warehouses and cold buildings, a million of euro cost, nowadays it's just a matter of some clicks and your service or your app is live. So life is more easier now, and this is the beauty of the cloud service providers. As we can say that there are some automation tasks which it could do, some operational stuff and scaling stuff it could do. For example, in normal setting, I can remember that you didn't plan very well the database, and that times the storage was so costly, and you managed to run your application on small database on small computer, and it turns out that many users are using this amount to try this, and at some point you figure out that your storage is out and you need to migrate to another computer, and you need to plan that like for weeks, and you do a lot of work, and then it's happened that you securely transmit the data set, transfer it, and then connect back to the application, and then application is working and everyone is happy, like you have sent the rocket on outer space. But now, like, it's a matter of click and done. This is the beauty. RDS could manage these kind of data sets, which is Postgres, a well famous data set database, in MariaDB, Oracle base, and Microsoft base. These are the well famous stuff in the market. And on the top, Amazon has its own DB, which is built on the principle of more faster and more reliable and more record within the milliseconds. Is with good indexing sources, built on the top of the open source, stuff, on the Postgres maybe. And the good thing is that you can always access these databases, whatever you created with PSQL from query lines or Workbench. Workbench front end, where you can see your table and manage the data, and these all you can do, right? This is some promotion from the Aurora. It's okay. Well, now comes to the non-relational database, and non-relational database, the one and only is DynamoDB in the AWS, and as I discussed that why sometimes you need that, it's highly scalable, it's designed to give you 1 trillion requests per day, which is a great number. And as I said earlier that how you migrate data set with AWS, and for example, AWS has a special service to migrate your databases easily from one resource to another resource, called the AWS TMS. When it comes to, you can cross that bridge, and then it's ask you that when to use relational database and when to use non-relational database. So when it comes to storing data in relational space, then definitely you need a relational database here, right? And storing database in key value page is non-relational, of course. Using SQL to organize data like server SQL query language, definitely this is relational stuff again. Scaling up to 10 trillion is non-relational, like DynamoDB. Storing data is Amazon Aurora is already a relational database service. And running data for serverless, I guess NR is the good option. Great. So there are some additional services which is really important to notice here. Well, for the big data, for example, you have multiple databases. You have 10 databases from you're giving 10 different sources, 10 different applications, and you have multiple databases, and somehow your services are, for example, your insurance company and you're offering the accidental insurance, life insurance, you're also offering some legal insurance, and you're also offering some other services which is related to area. For example, you also offering people protection during the traveling, and you have rental and hoteling business along together, but somehow your customer base is highly connected, and you have big data and you want to analyze it. And nowadays, this service is not, very unrealistic. In that scenario, you always need big databases like big data, and Redshift is one of the big data in that space, right? Like data warehouse, like Snowflake, and like data lake, similar to that. And then they have specialized data, which is MongoDB data or Rock's own MongoDB, which is essentially designed for document only. And then this is Neptune is graph-based data, again, graph-based data. So what I discussed, that why the graph-based, and what is the graph-based, where you have notation or the relation of one object with the other object stored in the table, but not the data itself. Because for you, data itself is not important, but for you, the relationship between data is important, and you store the relation when it is complex relation. This is kind of OLQB is a ledger base or historical base, where, for example, this is mostly used in the blockchain or in the crypto, for crypto stuff, where you need to create a copy of every single transaction. And once the transaction is written, you cannot delete it. You cannot do that because the trace is immutable or unmodifiable. And everybody knows in the ledger that what happened when. That is the beauty of blockchain. If you're more into, you can just. So yeah, Elastic Cache to create an improved database. This is again premium version of the DynamoDB accelerator. Not to discuss. Yeah, this is kind of stuff. And if you want to have some more insight into, you can read this multiple questions. What is the primary benefit of using S3 Intelligent, for example? As we have discussed, that why we use intelligence, because it's automatically optimized patterns. What is true for the intelligence, because it's automate stuff. And similarly, object storage, which services use good for object storage, always S3. Elastic block servers is a kind of block storage, and C is true. And what storage services is designed for long-term data archiving? It is Glacier service, right? And Amazon EFS, Elastic File Services, for which type of workload, when you need to do something scalable. Then which of the following storage types is for the running relational databases in EC2 instance? Yeah, for sure, EBS block, as I have shown you on the storage type. And what is the key benefit of using EBS? Because it's scalable and persistent, and don't delete when you delete it. And how you can retain the data, you have snapshots process actually. And for databases, what is the RDS? RDS, fully managed services, which simplify the operation. So it's doing the multiple zone, that's why it's more reliable. Yeah, it's mostly rely on the C block, right? Migration, we have some special stuff, as we have seen, for the database migration, right? And this is for the data warehousing, as I discussed. Redshift, which feature of the AWS Amazon allows queuing data directly in S3 without into Redshift? Spectrum. So common use case is data warehousing use case and analytic use case. So yeah, large scale data set with the query performance where you have petabyte of data and it takes hours to queuing all data. It has some upper layer of optimization which make it possible through that. Yeah, these are some sample questions for the module 4 which could appear on exam. Thank you. Yeah, what I can do is that might be very quickly I can show some stuff on EC2 instance S3. S3 is S3 Glacier. As you can see, you just need to create that. If you need archiving, and you can connect to your existing service. For the bucket, it's very easy. You can say that S3 test bucket. You can, if you have some previous bucket, you can always choose the same policy. You can also enable the allow control list, and in this allowed control list, you can always add and delete stuff. Right, and then this is the public access is blocked. For example, if you write your S3 similar to that web address, you cannot access it. If you want, you can disable this, and you can, for example, you have HTML and you want to serve and use ACL as a bucket as a web server direct rendering your page, then these are your options. Otherwise, you need to block it. If you enable versioning, it's automatically create a version of your bucket and store it automatically, right? These are the options we have seen already. Tag is the optional. You can use it if you want to. There are different, encryption method you can use, and then comes object log, right? And then once you create the bucket, and then you can see some stuff in the manage. Okay, this character is not permissible. So this name should be uniquely identifiable, because internally AWS has its own infrastructure which makes stuff possible. That's why they always want that stuff is uniqueable and name is permissible. And yeah, your S3 is there. And if you want to manage it, here is the management. You could do a lot of stuff. You can create a lifecycle rule, and in this lifecycle rule, you can say that archive it and limit the scope of using. And you can move this to different storage class, right? If the object size is this one, move this, otherwise don't move it. So there are some handy options. You can say that if the file name is start with this prefix, and then move it, otherwise don't move it. And here are some options. Move the current version of object between storage class. So here actually you can shift your storage class from standard. You can move it to intelligent, IA zone, one zone IA, glacial instant, what we have discussed, deep archive. These are the different storage type we have discussed earlier. You can select one of them here. For example, I want to move it to intelligent or whatever. And then all the objects which are in this test bucket source, will have this life cycle rule. Yeah. So you can also specify that after the 100 days or after 365 days, after 1 year, my object, because they are not anymore usable by the user, or user are less likely to use because we have seen this pattern, and please shift them to the uh, infrequent, or to the LA, to less accessible, less frequently accessible. I don't know what does it mean by EIA now. I forget it. I just mentioned it earlier, but yeah, you know what I mean. And when you hit here this create rule, and that's gonna create it for you a new role with this preview here. And you can also export this, because you can sometimes say, okay, this rule is gonna work for some time, and then please export it, and you can export it. So if you want to upload something, you can come here, and you can always upload your stuff from this file. So yeah, that's how actually the S3 storage and different classes of storage works, and databases and different style of databases, and relational and non-relational databases. Plus we have also seen that in which use case which kind of sources to use and which kind not to use, and what is the stuff with respect to the use case, because Amazon has kept in the mind the philosophy of the different use cases and need of their services to be designed in that way to serve the businesses in the efficient and optimal way. Yeah. So other than that, based on the frequency of use and kind of the usage, there are different style of usage like file system, elastic file system, and different type of storage of the object. Thank you very much for watching. Stay tuned for the coming up module up to the module 10. Later on, we'll record some courses for the associate level, which means that AWS associate level, designed for the architecture, where you know in detail regarding the sources and you practice it as well. Thank you very much. Bye.